Workers raised Liberty without today's enormous construction cranes. The statue arrived as hundreds of separate components. Copper panels covered a hidden structural framework inside. Workers needed careful methods for raising each section. No single machine could simply lift everything upward. Instead, crews relied upon scaffolding, ropes, and pulleys. Massive sections slowly climbed above New York Harbor. Each connection brought the monument closer toward completion. But reaching the highest sections created greater dangers. So how did workers raise this enormous statue? Tell us where you're watching from before we begin. The statue began as an ambitious French artistic vision. Frédéric Bartholdi imagined liberty represented through monumental human form. His design needed extraordinary scale from its beginning. Such size created problems traditional sculpture methods couldn't solve. Bartholdi first developed smaller models for study. These models gradually became larger through careful enlargement. Eventually, workers created an enormous full-sized plaster model. That model provided dimensions for the copper exterior. But copper could not support itself at this scale. A separate structural system therefore became absolutely necessary. The outer surface needed strength without excessive weight. Workers chose thin copper sheets for the exterior. These sheets could be shaped using specialized techniques. Repose allowed craftsmen to hammer copper into forms. Workers shaped panels against prepared wooden supporting surfaces. Repeated hammering gradually created recognizable facial features. Other panels formed robes, hands, arms, and crown. Each section required careful shaping before final assembly. The copper surface therefore became a collection of panels. Those panels eventually covered the entire monumental figure. Meanwhile, engineers studied how the statue could stand. The internal structure presented a completely different challenge. Wind would constantly push against the enormous surface. The framework needed strength while remaining relatively flexible. Engineers developed a central iron structural arrangement. This skeleton would eventually support the copper exterior. Its design required careful consideration of movement forces. Connections needed enough flexibility for changing wind conditions. The framework also needed to distribute weight effectively. Every major copper section received supporting structural connections. This approach separated appearance from the main structure. The copper skin could remain comparatively thin and light. The internal skeleton carried most significant structural forces. Construction therefore happened through several different processes. Artists shaped plaster while craftsmen formed copper panels. Engineers designed iron supports around those surfaces. Workers manufactured components separately before final assembly. This created an enormous industrial coordination problem. Thousands of individual pieces needed proper identification. Each section eventually required a specific position. Workers marked components to simplify later reconstruction. Temporary assembly helped verify dimensions before shipping. Large portions could be fitted together beforehand. Any mismatch became easier correcting before overseas transportation. This preliminary work reduced uncertainty during final erection. France's workshops gradually filled with enormous components. The statue's head became an engineering project itself. Its facial features required enormous copper sections. The raised arm presented another unusual construction challenge. The torch needed structural support far above ground. The crown required multiple points connecting to framework. Each part remained manageable only after careful division. Eventually, the complete figure existed in sections. Workers could no longer treat it as sculpture alone. It had become an enormous engineered assembly system. The distinction mattered once transportation plans became necessary. A completed statue could never cross Atlantic waters. Its components instead needed careful disassembly and packing. Workers prepared sections for the long ocean journey. Copper panels were separated from temporary assembly arrangements. Structural pieces were organized according to future positions. Everything needed protection against movement during transportation. The statue's journey toward America was finally beginning. But reaching New York was only another beginning. The real challenge waited beside the harbor. There, workers would transform scattered pieces into Liberty. The statue could not travel toward America fully assembled. Workers therefore dismantled sections into manageable transport pieces. Each component received careful protection before leaving France. Copper panels needed protection against damage during transportation. Iron framework pieces required separate packing and organization. Workers prepared wooden crates around numerous individual components. Every crate received markings identifying its future location. This organization prevented confusion during American Reconstruction work. The packed components eventually reached the French coastline. Ships carried the disassembled monument across Atlantic waters. The journey exposed everything to unpredictable ocean conditions. Strong waves could shift poorly secured materials inside. Workers therefore secured cargo throughout the voyage carefully. After crossing the Atlantic, the shipment reached America. New York Harbor provided the dramatic destination for Liberty. The enormous cargo finally arrived near Manhattan's shoreline. Workers began unloading crates from the transport vessel. Each component needed careful handling during this process. Nothing could simply be dragged across the construction. Copper panels could bend under careless handling pressure. Iron framework pieces also required controlled movement throughout. The construction site stood upon Bedloe's Island. Workers had already prepared the monument's massive pedestal. That foundation would eventually support the complete statue. Its enormous masonry structure rose above surrounding ground. The pedestal created another major construction achievement there. However, the statue remained scattered across temporary storage. Workers needed to transform those pieces into structure. They first organized components according to their markings. Iron sections were separated from copper exterior panels. Smaller parts required careful inventory before assembly began. Missing pieces could create serious delays during reconstruction. Workers therefore maintained detailed records throughout unloading operations. The island gradually filled with construction materials everywhere. Crates occupied areas around the unfinished pedestal. Framework components waited beside copper sections nearby. Scaffolding materials arrived alongside ropes and lifting equipment. The construction site became an enormous outdoor workshop. Before vertical assembly could begin, workers studied plans. Engineers reviewed the original French construction drawings carefully. Those drawings showed how components belonged together. Workers compared markings against the engineering documentation repeatedly. This process helped prevent assembly mistakes later. The internal framework received special attention from engineers. It needed to connect correctly with pedestal supports. The copper exterior depended upon that hidden structure. Without proper framework alignment, panels could not fit. Therefore, assembly began from structural elements first. Workers erected portions of the internal framework gradually. Temporary supports held sections during early assembly stages. Scaffolding surrounded areas requiring elevated access for workers. Platforms provided working positions around unfinished structural sections. Ropes helped move smaller components toward higher platforms. Larger sections required stronger lifting arrangements above ground. Mechanical advantage allowed workers to move heavy pieces. Pulleys reduced the effort needed during controlled lifting. Teams worked together while guiding suspended components carefully. Communication became essential whenever large pieces moved upward. The lower framework slowly began taking recognizable form. Workers attached additional supports around the central structure. Copper panels waited nearby for their eventual installation. Each panel needed correct positioning against supporting framework. The reconstruction process was gradually becoming vertical. Every completed section brought the statue higher upward. The harbor offered workers a constant reminder nearby. Millions of people would eventually see this monument. But the workers still faced enormous structural challenges. The framework needed to carry the statue safely. Wind could push against the enormous copper surface. That force would increase dramatically with greater height. Engineers therefore monitored structural alignment throughout assembly. Temporary supports remained essential during vulnerable construction stages. Workers could not remove them prematurely from sections. The statue was still incomplete and structurally dependent. Its final stability would come much later. Meanwhile, construction continued around the massive pedestal. Materials moved constantly between storage and assembly areas. Workers climbed scaffolding, carrying tools in smaller components. Other crews prepared copper panels for installation. Engineers inspected connections before allowing additional sections upward. The monument slowly stopped resembling scattered construction materials. Its recognizable figure began emerging above the harbor. Yet the most difficult work remained ahead. Higher sections would require increasingly complicated lifting operations. Workers would soon move massive pieces upward. Those operations demanded equipment, timing, and extraordinary coordination. Modern tower cranes offered no convenient solution then. Instead, crews would rely upon simpler mechanical systems. The statue was ready to begin climbing skyward. Liberty rose through scaffolding, pulleys, teamwork, and patience. Workers assembled thousands of pieces high above. No modern tower crane lifted this famous monument. Simple mechanical systems achieved something extraordinarily ambitious instead. Subscribe for more forgotten construction stories from history.